scholars. Okay.
Take two. Going.
Take two.
Rolling.
My algebra scholars. I'm going to take you on a hiking adventure with me today. I'm in the San Juan Islands. I'm on Orcas Island. And we're going to go on a hiking adventure. So I had to wait until the hike was done to be able to help you set up your graph. So I know we're just starting. Hopefully your teacher told you to get out your journals. And by the way, it was not this wet when we started this hike. So as you can see right now, we set out to hike Mountain Lake Loop. It's 3.9 miles all the way around the lake. Very little elevation gain. That's what we set out to hike. But our hike actually ended up close to 6 miles. And you'll discover why that is as you go on this adventure with us. But I need you to set up your graph so that you can virtually hike with me. So you're gonna make a little, remember the T-charts in Algebra 1? But you aren't gonna use all 4 quadrants because Ms. Marquardt only hikes positive time and positive distance. So you only need your L-shaped graph, which is your quadrant 1. And remember, we've studied domain, left to right, and range, bottom to top. So I had to finish the hike to be able to tell you how to set up your domain and your range. So we're gonna set up, time is on the x-axis, time is your independent variable. So it took me, if I take a look at this, Jace, how long did it take us to go? I lost mine.
2 hours and 34 minutes and 20 seconds.
2 hours and 34 minutes. So you guys are gonna set it up because we're doing by minutes. 6120, you're gonna set up your x-axis to be 150 minutes. So your teacher's gonna help you do that. I can't get my glove back on, it's so wet now. Your teacher's gonna help set up your graph so that your domain is from 0 to 150, and you have to label it time in minutes. And then your range is the distance that we've gone hiking. So the total distance that we went hiking today was almost 6 miles. So your teacher is gonna help you set it up, and you're gonna talk about miles versus feet, which one is probably the best one. And then guess where I started, kids? Guess where we started the hike? At the origin, 0, 0. I hit start on my watch. No feet had passed, no time had passed, 0, 0. And what I want you to do to start is I want you to graph the very end. I want you to graph 150 minutes, took 5.75 miles. I went 5.75 miles in 150 minutes. Remember, slope is a rate of change. It only takes 2 points in time. So you're just gonna estimate. I know where Ms. Marquardt started. I know where she ended. And you're just gonna have a beautiful linear function that goes all the way start to finish. But that makes me look like we hiked that exact same time and rate for the whole hike. No, because math isn't perfectly linear. All we use it for is a prediction, an estimation, a guide, but that's not really true. That's not really what happens in real life typically. Okay, I also want you to think what happens if we start hiking faster. What happens when a mountain bike blazed past us on the trail? Would his line be steeper than ours? Flatter? My husband had a sprained ankle. You're gonna get to see that awesome footage. He slowed us down a little bit in parts. No, you didn't, sweetheart. No, you didn't. I slowed you down. Killing me. So what would that do to the graph? So have a few chats with your teacher about that. And then you guys get to go hiking with me. However, one last thing. When we go on hikes, we always wonder things. Wonder, kids, like, I wonder why that mushroom grows on that tree like that. I wonder why this particular tree has fallen over. I wonder why there are people on these trails without masks still. Right, but I wonder things. And start wondering even as you're hiking with me. And then at the end, you can talk to your teacher about all the things you wondered. Like, I wonder why this lady's husband married her when he has to film her crazy adventures.
I'm like the Instagram boyfriend.
All right, so pause it right now, stop it, talk to your teacher, get your graphs all set up, and then you guys are gonna start hiking with Ms. Marquardt. See you soon!
3, 2, 1, going.
Okay, we're here on Orcas Island, and sometimes when math moves, sometimes we determine how high of an elevation change, like the last hike we went on when you saw me going crazy and breathing really hard. Sometimes you measure your change in elevation over time, and sometimes you want to know how far you've traveled in a certain amount of time. So today we're at Mountain Lake, and we're gonna hike around Mountain Lake, and we're gonna keep track of our change in horizontal distance, our change in mileage over time. And And that creates a different graph than when you track your change in elevation over time. So let's hike Mountain Lake. Okay, so we're 1 mile in. I've hiked exactly 1 mile. And remember, on this hike, we're not going for elevation. This hike, we're going for total distance hike, right? And on the sign, it said 3.9 all the way around the lake. So we've gone 1 mile. And it took me, according to my watch, about 21 minutes. Remember, algebra's math that moves. So that means that algebra can also help us predict. So if we walked 1 mile, my family and I walked 1 of the 4 miles around the lake in 20 minutes, that means that 3 more miles would take us 20 more minutes, 20 more minutes, 20 more minutes, 20, 40, 60. It's gonna be another hour from this point to finish our hike and get back to the Jeep. So what I want you to do, my husband's laughing at me right now, maybe with the realization of 1 more hour on this trail.
No.
Or maybe my hair.
It's the wind that started picking up.
I just swallowed my hair. Okay, so what I want you to do is I want you to find my average rate of change, right, as a unit rate. So I want you to divide, like, how long does it take me to go per foot, right? How many seconds, hopefully not a minute, would it take me to go per foot, right? And you're putting on your graph 1 mile, 5,280 feet, in about 21 minutes. I took a picture of it, okay? And I want you to map that. And then I want you to predict about how long it'll take us to finish this total hike. Let's Okay, so at the start of the hike, I told you that sometimes we can graph our hikes and our progress based off of elevation, and sometimes we can model the data based on our horizontal distance, the distance we travel. So we're at this cool point right now where I could choose to model the data either way, because even though this is a flat trail around a lake, it still has elevation gain. So my watch right now tells me that I'm at 123 feet of elevation gain on this hike. We just came up a little bit of hill, and you can see down here that we're now above the lake. So if I were to graph this data, it would be completely different if I were to do it based off of elevation, because that means that I would only graph 123 vertical feet in 30 minutes of hiking. But we're doing a total distance graph. We're not taking into account elevation. So we've gone 1.22 miles, which is about 6,500 feet elevation. So our scales would have to be different. They would both be a time of 29 minutes, but one of them on the y-axis would only need to go to 123 feet if we were graphing elevation. But because we're graphing total distance, now it needs to go up to like 6,500 feet, even though it's the exact same hike. All right, so we hit a sign. We're doing the loop around, and we hit a sign that says, want to go to Twin Lakes? It's only another 0.8 miles to Twin Lakes, and then we got to come back, right? But I think there's going to be elevation gain, guys. I think there's going to be elevation gain. So maybe we would have to do another graph that's total distance and a separate hike that has elevation gain. Woo! Okay, let's make a note. I'm at 123 feet of elevation gain. Can you guys see that? Right now I'm at 123 feet of elevation gain, and 33 minutes into the hike, and we've gone 1 1/3 miles, 1.3 miles. All right, hey, let's see what Twin Lakes looks like. Yeah! Okay, as we start this hike, I have a challenge for you kids. I want you to think about the fact that we're now not hiking flat, that we're now gonna have to hike up in elevation to get to Twin Lakes. So I want you to think in your brain, scholars, think in your brain, if I were just to graph total distance over time, there's my son being a weirdo back there, you know that we're probably gonna have to hike slower to go uphill, right? I mean, we probably can't hike as fast uphill as we hike on the flat. So how will us hiking slower affect this part of the graph that you're gonna see, right? We're changing our speed, we're changing our rate, and you know we're gonna hike slower because of the elevation change. So think about that in your brain, and then we'll graph it. All right, we stopped. You can see my watch says 2 miles, right? 2.01, but 2 miles, 50 minutes. So we went the first mile in 21 minutes. Next mile, not 21 minutes. So when you go to graph it, I know, I told you guys, we took a little detour. What's gonna happen if it took us more time to go the same distance? Will your line be steeper or flatter? Graph it. See you soon. Cool part of the hike, everybody. Hey, has anybody pointed out while they're graphing, has anybody pointed out to their teacher that every time Mrs. Marquardt stops and talks, that shouldn't count as part of the distance over time? That Miss Marquardt is having zero fun? That, I mean, like right now I'm walking and talking, but whenever I stop and talk to you guys and like 3 minutes go by, what would that look like on your graph? To graph that we're not moving, that my son is having zero fun, mainly because he's listening to me talk about math on a hike. What would that look like on a graph? And how would that actually alter my average rate of change? I wonder if anybody's pointed that out to Mr. Anderson or Mr. Keebler or Mr. Pope or Mr. Anderson or Mr. Kwan. Woo, there's so many of us, you guys. Maybe Miss Brooks' kids pointed it out. I don't know, maybe Miss Hernandez's kids pointed out. Awesome. Let's keep hiking though. Let's keep this math moving. I think we're coming up to the lake. Sorry about this bumpy ride. I see water. That really wasn't bad. That elevation change was not bad. Let's see. We're at 323 feet elevation gain. So we changed 200 feet we went from 1.3 miles to 2.06 miles. So about 2/3 of a mile.
Twin Lakes just says 0.1. We
changed. That's because, so Twin Lakes is not, this is the first lake. And then the second little twin lake, remember twin, there's two, is 0.1 this way. Let's go find it. All right, so we made it to Twin Lakes and we were debating whether or not to keep going up to Mount Constitution because it's only 1.5 miles further. 3 more miles round trip. We could do that. We got food, we have water. And even though we know it's gonna be at a higher elevation, we also brought extra clothes. But here's the thing. We know that these lakes are at 1,100 feet elevation. And even though it's only 1.5 miles away, which isn't bad, Mount Constitution is up at 2,300 feet elevation. So we would be climbing 1,200 feet up in elevation over just a short 1.5 miles, which tells us that that part of the hike is going to be much steeper than what we've already climbed. So my scholars, I want you to imagine, what would that hike look like on a graph? What would that do to our graph if we were to put it on our grid paper right now? But we're not, we're gonna turn around and keep going back down. We're gonna head back down where we came from to Mountain Lakes and finish that hike. Alright, so I found my Gandalf the Grey stick, right? Because I always call him Gandalf the Great, and my son corrects me every time. So, walking stick, it's a little big. I wanted you to see, as we head towards Mountain Lake again, that the water is actually coming down, right? Science kids, you guys are studying this in your science classes. The water runs down from the snow melt and is what makes the lake. So awesome to swim in this spring. But I also want to tell you, we have hit 3 miles, 3 total miles, 80 minutes. 80 minutes. So if you remember way back mile 1, it took us about 21 minutes. And if I had hiked at a constant rate of change, that would have been 21, 21, 21. That should have been 63. We hit 80. Oh, right? So constant rate of change is like just something mathematical that we use to average, to predict, to study. But it isn't really real life. Like there were times like right now, 2 minutes of just standing here. Is my distance changing? No. Is my time still going? Yes, because even though I'm Gandalf the Grey, I can't stop time. It just keeps going. So now 3 miles. We're gonna try and get to 4 miles without stopping so we can actually see what our average rate of change, what a constant rate of change would look like from mile 3 to mile 4. Move out! Did you just crunch your apple in my video?
Mm-hmm.
Cool, so we're almost done with Mountain Lake hikes and we came across a dam. Didn't really even know that this lake...
This is what creates the lake.
Yeah, to dam up the water, to keep it from going downhill and flooding too quickly. So, pretty awesome. And then you guys can see those are called booms right across there. The horizontal look like dashed lines across. And that's to keep people out on kayaks or rafts from getting too close. Really cool lake.